Let's look at an example of how to find the cross product of two vectors. So here I give you two vectors, 2i minus j plus 2k, and w is j minus k, and I'm asking you to find v cross w. It might be helpful to write these vectors in component form. So this vector is 2, comma, negative 1, comma, 2, and the vector w is, notice there's no I term, so it's 0, comma, 1, comma, negative 1. Okay, to find the cross product of two vectors, we form a 3 by 3 matrix and then take the determinant of that matrix. And the 3 by 3 matrix that we make is always first row I, j, k. The second row are the three components of the first vector, so 2, negative 1, 2. And the final row, the third row, are the components of the second vector, w in this case, so that's 0, 1, and negative 1. And then, as you can see, I'm asking you to take the determinant of that matrix. That's what those two bars are. Alright, so how do we take the determinant of a 3 by 3 matrix? Well, we're going to go along the top row, and I'm going to take a determinant of a 2 by 2 matrix times I minus the determinant of some 2 by 2 matrix times the second element in the top row, j, plus, well, I'm going to take another determinant of a 2 by 2 matrix and multiply that by this element in the first row, third column, k. Now, what are the determinants I'm taking, the 2 by 2 matrices? Well, I want to cover up i's row and column. So I'm going to ignore this row and the first row and the first column. That leaves me with the 2 by 2 matrix, negative 1, 2, 1, negative 1. And I'll take the determinant of that in just a second. For the 2 by 2 matrix, I'm going to multiply by j. I'm going to delete j's column and j's row. That leaves me with 2, 2, 0, and negative 1. And then finally, for the 2 by 2 matrix that I'm going to take the determinant of and multiply by k, I delete k's row and column, so that leaves me with the 2, negative 1, 0, and 1. 2, negative 1, 0, and 1. Alright, so now let's take those 2 by 2 determinants. I go main diagonal, negative 1 times negative 1, that's 1, minus 2 times 1, so 1 minus 2 is negative 1 times I, minus, let's see, main diagonal would be 2 times negative 1, that's negative 2, minus 0, so that's just negative 2, j. This first negative is from the formula for determinant, but I'm going to have a negative negative, that'll become a plus in just a second. And then plus, let's see, 2 times 1 is 2, minus negative 1 times 0 is 0, 2 minus 0 is 2. 2k. Alright, so altogether here I have negative I plus 2j plus 2k. Or if I want to write that in component form, I would have negative 1, comma 2, comma 2. Alright, and there's the determinant of that matrix, which is the cross product of those two vectors. A quick check. This cross product I just found is a vector that should be orthogonal, that is perpendicular to both v and w. So let's just quickly check that it is. Let's take the dot product of this vector we just found and v, and then take the dot product of the vector we just found in w. So we do 2 times negative 1. 2 times negative 1 is negative 2. Negative 1 times 2, that's negative 2 again, so we're up to negative 4. And then 2 times 2 is 4. Add those all up, you get 0. Okay, looks good. And also check dot product of w and this cross product. 0 times negative 1 is 0. 1 times 2 is 2. Negative 1 times 2 is negative 2. Add those all up, you get 0 as well. So this definitely looks like we didn't make any mistakes. Alright, well, why don't we try just one more, and I'll let you try it on your own, and then we can, I'll do it, and you can check your work. So let me just make one up off the top of my head. How about the vector 2, 3, 1? and we'll do the cross product of that with the vector 4, 2, negative 2, say. All right, give that a shot. I'll pause the video now, and we'll come back and try it together in just a minute. All right, well, let's take a look. We're going to make a 3x3 matrix. We'll have I, J, K as the first row, then 2, 3, 1, and then 4, 2, negative 2. All right, this will be, we're going to get something times I minus something times J plus something times K, and those will all be 2x2 determinants, but in the interest of time, let's just go ahead and do those out. The number here should be 3 times negative 2. 3 times negative 2, that's negative 6, minus 2. Negative 6 minus 2 is negative 8. All right, for the coefficient of J, we look at the 2 times negative 2, that's negative 4, minus 1 times 4, that's 4. Negative 4 minus 4 is negative 8. So we're subtracting a negative 8, that becomes plus 8J. And then finally for the K coefficient, I look at 2 times 2, that's 4. 3 times 4, that's 12. So I have 4 minus 12. 4 minus 12 is negative 8. It becomes negative 8. All right, so the cross product of these two vectors is the vector negative 8, 8, and negative 8. And there we have it. All right, well, I hope this has helped. Thanks for watching.